Good evening, Dr. Shafiq. My name is Hvac, and today me and my groupmate gonna present about our Hvac project about the badminton hall for UTHM at Parit Raja. So for my group member, including myself, me, Hvac, and Lee Sing Sian, Nor Fakiha Izati binti Ramli, Nor Khairunisa binti Abdul Karim, and Nur Amira Azria Kilah binti Zulkifal.
Assalamualaikum. We are from Group 3. We are going to present our project Hvac Design for Badminton Hall. First, I'm going to do the introduction. Hvac, which is heating, ventilation, and air conditioning, is a system that regulates the temperature, humidity, and air quality of indoor spaces. There's a few components that included in the Hvac system, which is furnaces, boiler, various type of ventilation system, and also air conditioning unit. For our project, we are going to know the importance to accurately calculate the cooling and ventilation loads. This is to ensure the occupants' comfort, reduce energy consumption, and also to maintain indoor air quality IAQ. We also, in this project, we are going to focus on comparing two methods in determining the cooling load at the badminton hall. We use advanced simulation of Revit software and also the traditional way cooling load temperature different CLTD method. Next is our project objective. First, we are going to compare the cooling load result from the Revit software and CLTD. Second, we are going to analyze the ventilation requirement. And lastly, we are going to discuss the impact of Hvac design on energy efficiency and IAQ. And the last part I'm going to present is scope of study. So for our project, we are aim to an accurate cooling and ventilation load, which is this is required to provide user with a comfortable and energy efficiency environment. We also need to know the ventilation requirement where we analyze the data on the occupancy level and the air exchange rate to maintain the IAQ. And lastly, we are going to evaluate the accuracy of the result for both methods, which is Revit software and CLTD. We are going to compare and determine which method are more reliable and practical in Hvac system design for badminton hall.
Assalamualaikum. My name is Nur Karenisa binti Abdul Karim. So I will explain on the heating, ventilation, and conditioning design process from start to end of this project. Okay. First of all, the HVAC design process begins by gathering details information about the building functionality, materials, and quality to ensure the system meets its specific needs. Next step is the indoor air quality requirement are determined, followed by the creation of HVAC design based on this criteria. A cooling load calculation is performed to assess the heating or cooling required, and suitable HVAC system and components are selected accordingly. The design is then checked for the compliance with recommended standard. If it fails, revision are made until compliance is achieved. Okay, once it's approved, a detailed layout plan is created, leading to the completion of the finalized HVAC design, and it's ready for the implementation.
For our design layout of 3D image, we use Revit to design it based on the standard requirement of the aerial, which is 1040 meter square for our 3D design of the badminton hall area. These are the specific value for the horizontal and vertical value of the hall based on two dimension. For the comparison with Revit software and CLTD manual calculation, the total cooling loads for the CLTD that we have received, which is 165.33 kilowatts, which is 57%, and for the Revit software is around 124.63 kilowatt, which is 43%, and the difference around 14%. And for the sensible load, around 117.37 kilowatt, which is 53% for the CLTD method, and for the Revit, which is 102.86 kilowatt, which is 47% for the Revit software, and around 6% difference between those two. And for the latent load, which is 40.05 kilowatts, which is 66% for CLTD method, and for the Revit software is around 20.34 kilowatts, which is 34 percentage, and CLTD method shows 32% higher than the Revit software. For the cooling loads analysis shows that Revit software estimate a cooling loads of 124.63 kilowatts, which is 38 BTUH per feet square, that align with the modern minimum standard of the rule of thumb. And while the CLTD was estimated at the average level of the rule of thumb standard, which is the value at 165.33 kilowatt, which is 50.4 BTUH per feet square, and slightly different than the Revit software was due to then about the U factor changes during the years due to the COVID-19 and some environmental condition that need to change to comply with the new standard. And for the sensible loads, the Revit software estimate around 98.9 W per meter square, which is around 31.3 BTUH per feet square, while the CLDD method estimated around 112.9 W per meter square, which is around 35.8 BTUH per feet square. And it was slightly overestimated for the rule of thumb. And for the latent loads, the Revit software estimated around 19.56 W per m square, around 6.2 BTUH per feet square, while the CLD method estimate a higher value of 38.5 W per meter square, which is 12.2 BTUH per feet square, and reflecting the difference in assumption about the humidity and occupancy. So for the ventilation rates are 6.6 LPS per meter square, meeting the recommended 8 to 10 LPS per person for the badminton hall. And for the air changes per hour, which is ACH, is around 9.9, with the recommended range of the 8 to 10 ACH. This value demonstrates the excellent air circulation, humidity control, and comfort, and making it the badminton hall highly suitable for intense physical activities and high demand usage.
Next, I will explain on the energy efficiency and indoor air quality of Hvac system. As we can know that ventilation in Hvac system affects energy use, thermal comfort, and indoor air quality that requiring strategies tailored to the climatic variation and specific indoor condition. Okay, in these sport facilities like badminton halls in this project, is maintaining low temperature and optimal air velocity is crucial due to the occupant activity and the heat sources. Effective ventilation demands through system inspection, clear maintenance, regular staff training, and the integration of smart control and IoT enable dashboard for efficient and transparent building management.
The next part is Internet of Things system, which is IoT. IoT provide a proper solution since it provide a way to connect sensor, actuator, and other object to the internet, and therefore, to perceive the example, using the IoT sensor, it may be measured in if a room is occupied or not and control the use of cooling or heating. To enhance the efficiency of HVAC system, so the next suggestion is we can install building management system. The BMS system collect all the required information that will help system determine whether or not to control the heating and cooling system to get the best of that environment as far as temperature and energy is concerned. The BNS will switch on or off all systems that at the appropriate time in order to maintain required temperature in premises under consideration. Here is the benefit of building management system. The first one is controlling thermal energy with the identification of the average temperature of the building, and it can even identify and prevent likely system problem. The second one is we can set point to control the minimum and maximum allowable temperature in each room. For example, limiting the minimum maximum threshold, the uninformed alternation, or even deliberate manipulation of the data can be avoided. The last is control the temperature in each room and adapt during an event. Either door and window are open and vice versa. The last one is variable air volume system, which is VAV system. So VAV system is significant and specifically delivered to allow for intelligent altering of temperature and ventilation in structure. In a VAV system, each drone is provided with a VAV box, which generally contains a damper used for varying the airflow rate. It operates by moving the position of the damper so as to control the quantity of the conditioned air supplied to a particular zone while at the same time creating a constant supply air temperature.
For the conclusion, our analysis of the Hvac system design for the badminton hall highlighted significant findings. The comparison of cooling load estimation method revealed that auto derivative provide more precise and realistic approach compared to the conservative overestimation of the CLTD method. The ventilation system we analyzed align with ASHRAE 62.1 standard, ensuring optimal air exchange and air quality for high activity indoor environment. Overall, the purpose HVAC design meet the functional demand of the badminton hall while maintaining energy efficiency and suitability for a tropical climate. Okay, next for the recommendation to enhance the efficiency of and reliability of HVAC design, we propose a hybrid approach. The CLTD method should be used in the preliminary stage for quick and reliable estimation, followed by precise load and computation using AutoDerivative in the later stage. Additionally, integrating energy efficient technology like variable air volume system, demand control ventilation, and heat recovery ventilator can significantly reduce operating costs while maintaining comfort. Finally, the periodic system optimization is also essential. Regular adjustment and maintenance will help adapt to change in weather, occupancy, and emerging technologies, ensuring long-term system effectiveness and readiness for future demand.